When installing a subpole in a metal garage, grounding is a critical aspect to consider for safety and code compliance. The question of whether a ground rod is required, especially when the metal building sits on a concrete slab, is addressed by the National Electrical Code, specifically Section 250.52 A2. It's important to understand that metal buildings on concrete slabs have specific grounding requirements as outlined in 250.52 A2 or B. These sections provide options for grounding. Option involves using a rod or pipe, specifying that a copper-clad rod or pipe must be driven at least 8 feet into the earth. The location of this rod should be at a distance not less than 6 feet from the building. Option B details encircling the building with a grounding ring comprised of a bare or insulated copper conductor. Despite the metal building being grounded, a ground rod is indeed still required, meeting the requirements of 250.52 A2. And means that one rod or pipe is generally sufficient. Now, let's examine the exception mentioned in 250.52 A2.1. This exception does not apply to metal buildings situated on concrete slabs. This clarifies that the metal building itself cannot serve as the sole grounding electrode. Therefore, in summary, even if the metal building is grounded and rests on a concrete slab, installing a ground rod is necessary. This ensures compliance with the NEC and provides a safe electrical system. To reiterate the installation process, drive a copper-clad rod at least 8 feet into the earth, ensuring it's located at least 6 feet away from the building. The NEC provides detailed guidelines to ensure electrical safety. Grounding is a critical safety measure in electrical installations. It provides a path for fault current to return to the source, tripping a circuit breaker or fuse and preventing electrical shock hazards. In the case of a metal building, grounding helps to minimize the risk of electrical potential differences between the building and the earth, which could occur due to lightning strikes or other electrical disturbances. The concrete slab itself does not provide an adequate grounding path, as concrete is not a good conductor of electricity. Therefore, relying solely on the concrete slab for grounding is not sufficient to meet code requirements or ensure safety. The ground rod, driven into the earth, provides a direct connection to the earth, allowing fault current to flow safely back to the source. This helps to protect people and equipment from electrical hazards. When selecting a ground rod, it is important to choose one that is made of a suitable material, such as copper-clad steel, and that is long enough to reach conductive soil. The 8-foot minimum length specified in the NEC is intended to ensure that the rod makes good contact with the earth. The location of the ground rod is also important. It should be located in an area where the soil is moist and conductive. Avoid locating the ground rod in areas where the soil is dry or rocky, as this may reduce its effectiveness. The NEC specifies that the ground rod should be located at least 6 feet away from the building. This is to prevent the building from interfering with the ground rod's ability to conduct current. In addition to the ground rod, it is also important to ensure that the metal building is properly bonded to the grounding system. This means that all metal parts of the building, such as the frame, siding, and roofing, should be connected to the grounding system with a suitable bonding conductor. Bonding helps to equalize the electrical potential of all metal parts of the building, reducing the risk of electrical shock hazards. The size of the bonding conductor should be determined based on the size of the service conductors, as specified in the NEC. It is also important to ensure that all electrical equipment installed in the metal building is properly grounded. This includes lighting fixtures, receptacles, and appliances. Grounding electrical equipment helps to protect people from electrical shock hazards and also helps to prevent damage to the equipment itself. The NEC provides detailed requirements for grounding electrical equipment, including the use of grounding conductors, grounding electrodes, and grounding electrode conductors. When installing a subpole in a metal garage, it is essential to follow all applicable codes and regulations. This includes obtaining the necessary permits and inspections. A qualified electrician should be consulted to ensure that the installation is performed safely and correctly. Improper grounding can create a serious electrical hazard, so it is important to take the time to do it right. Furthermore, consider the local amendments. Local jurisdictions sometimes amend the NEC with additional requirements or clarifications. It is crucial to check with the local authorities having jurisdiction or OJ to determine if any local amendments apply to the installation. These amendments may relate to the number of ground rods required, the size of the grounding conductors, or other aspects of the grounding system. Failing to comply with local amendments can result in failed inspections and potential safety hazards. The purpose of grounding is not just to protect people from electrical shock, but also to protect equipment from damage. A properly grounded electrical system can help to prevent voltage surges and other electrical disturbances from damaging sensitive electronic equipment. This is especially important in a metal garage, where there may be a variety of electrical equipment, such as power tools, welders, and other machinery. In addition to the ground rod, the NEC also recognizes other types of grounding electrodes, such as metal underground water pipes, metal building frames, and concrete encased electrodes, also known as UFA grounds. However, as previously mentioned, the exception in 250.52 82.1 specifically states that the metal building cannot be used as a sole grounding electrode for metal building on a concrete slab. Therefore, even if the metal building is connected to a metal underground water pipe or other type of grounding electrode, a ground rod is still required. It is important to understand the difference between grounding and bonding. Grounding is the process of connecting an electrical system to the earth, while bonding is the process of connecting metal parts of an electrical system together. Both grounding and bonding are essential for electrical safety, but they serve different purposes. Grounding provides a path for fault current to return to the source, while bonding helps to equalize the electrical potential of all metal parts of the system. In the case of a metal garage, it is important to both ground the electrical system and bond all metal parts of the building together. This will help to minimize the risk of electrical shock hazards and protect equipment from damage. When selecting grounding and bonding conductors, it is important to choose conductors that are of the proper size and type. The size of the grounding and bonding conductors should be determined based on the size of the service conductors, as specified in the NEC. The type of conductor should be suitable for the application. For example, copper conductors are generally preferred for grounding and bonding applications, as they are highly conductive and resistant to corrosion. Aluminum conductors may also be used, but they must be properly terminated and protected from corrosion. Before commencing any electrical work, it is essential to energize the circuit. This can be accomplished by turning off the appropriate circuit breaker or fuse at the main panel. It is also important to verify that the circuit is de-energized using a voltage tester before touching any wires or equipment. Working on a live electrical circuit can be extremely dangerous and can result in serious injury or death. If you are not comfortable working on electrical circuits, it is best to hire a qualified electrician to perform the work. Electricity is a powerful force, and it should be treated with respect. By following all applicable codes and regulations and taking the necessary safety precautions, you can help to ensure that your electrical system is safe and reliable. Remember to always consult the latest edition of the National Electrical Code and any applicable local amendments before performing any electrical work. The NEC is a comprehensive set of standards that provides detailed requirements for electrical installations. It is essential to stay up to date with the latest code requirements to ensure that your electrical work is safe and compliant. Furthermore, proper documentation is essential for any electrical installation. This includes keeping records of the materials used, the wiring diagrams, and the inspection reports. This documentation can be helpful for future maintenance and troubleshooting, and it can also be required by the local authorities having jurisdiction. In addition to the technical aspects of grounding, it is also important to consider the aesthetic aspects. The ground rod and grounding conductors should be installed in a way that is neat and unobtrusive. The ground rod should be driven into the earth as close to the building as possible, and the grounding conductor should be run along the building in a concealed manner whenever possible. By paying attention to the aesthetic aspects of the installation, you can help to ensure that the grounding system does not detract from the appearance of the building. Finally, it is important to remember that electrical safety is an ongoing process. Regular inspections and maintenance of the electrical system are essential to ensure that it remains safe and reliable. This includes checking the grounding system for corrosion and damage, and testing the ground fault circuit interrupters, or GFCIs, to ensure that they are working properly. By taking these steps, you can help to protect yourself and your family from electrical hazards. The principles discussed here about grounding apply to various structures and situations, but it is important to always tailor the application to the specific circumstances and consult with qualified professionals when needed. Electrical work can be dangerous, and it is always best to err on the side of caution.